column to the 45. Okay, so somebody forgot how to say 冒号. Semicolon should be this one, but semicolon is the first号, right? Or how to say 冒号? Column, is it column? Okay. Okay, let's just use column. All right. Okay, let's just extract information from the column 6 to the 45. And so you will see that they are the result is the 1,200 by 40 data. Okay. So now we already have the information for the male and female, and also we also extract information for the brain features. So that's what we need for the machine learning. What we need to do is that can we build a model to calculate something in these brain features and to output the result for the male and female. But in this case, it's a supervised learning because we already know the answers. We know which case is male and we know which case is female, but we intended that we don't know the answers in part of the data. For example, we could divide the data into the testing data. Then we intended that we don't know that answer. Then we can build a model for the training data and to test in the testing data and see if our model can work. So that is the everything about the machine learning. Okay, so suppose that everyone knows this part, then you will let's look into the brain features. Okay, so for the Excel file, it's just numbers. Also in the MATLAB, you can just take a look into the brain features here. Then you will see lots of numbers. Okay, and for these numbers, you will see that they are not equally distributed. Some columns have very large numbers, and some columns have small numbers. So that is the problem, because when you do machine learning, it's just like it's not like just the brain, how brain works. We can immediately see, okay, this is large numbers, this is small numbers. But for the machine, they will immediately attracted by the large numbers. So when you just put this data into the machine learning algorithms, usually the algorithm will be biased by these large numbers. Okay, so we want to normalize this data. Then how do we do normalizations? But before that, let's take a very, very simple look. Just what is the feature looks like? So for the first one is the intracranial volume, right? And when you plot the results of the first one, all the 1,200 cases, you will see that immediately you will see that the first half has a smaller volume, and the second half has a larger volume. That is because usually the male has a larger brain and the female has the smaller brain. That doesn't mean that the smaller brain is related to the intelligence. Usually the smaller brain is more intelligent, but actually you can see that there are significant differences. So that is one important feature. You can classify the male and female. You can just draw a line here to separate the male and female. But let's take a look for the other the variables. So if you want to look at the features, you just type into the plot. So plot means that you want to make a figure about something. So in this case, we want just plot one features. And for the one features, we can just type brain and specify the first column here. So similarly, we just want everything in the first dimension, and we want just the first column in this variable. Then you can just type this command, you will see the result. Okay, you can check for the other variables. For example, if you just want to look at the second variables, then see if also, okay, you can also differentiate the male and female. But let's take a look. If you just, for example, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, amygdala. Okay, so if you want to take a look at amygdala, then you will see that there's a difference between male and female, but it's not as significant as you see in the intracranial balance. And also, if you look at the thickness, like the variable 10, you will see that, okay, there's no difference. So, so although the female has the smaller brain, but the cortical thickness is almost the same in the male and female. That is very important because the cortical thickness represents how many neurons in our brain. So that is evidence that we have the same neurons for the male and female. Okay, so but that is one way you can look at the features. So remember, when you do the machine learning, just try to look at the features you have in your data, and you will derive some intuitions into your algorithms. Okay, so as I said, we need to do some normalizations. So the normalization means that you want to take out the effect of the mean and standard deviation, right? So you want to take out the mean, so every data you have has a zero mean. But you also want that your data is only one standard deviation, not the different numbers. So for doing this, it's a little bit tricky because you need to calculate what's the mean for each column. And you also need to calculate what's the standard deviation for each features. So the first two lines is try to do this. The first line we just type the mean functions. So for this line, we can derive the mean for each column. And also for the standard deviation, the function name is the STD. Okay, so we use STD to derive the standard deviation for each column. So let's just run these two lines here. Then you will see there are two new variables comes out. One is the M, which is the mean. So you can see that it is the mean for the first column, for the second one, and etc. And also for the standard deviation, you can see the results are all here. Okay, so, but now you want to, for example, you want to subtract the mean of the 40th columns into every numbers in this table, right? Oh, not this one, sorry. Okay. So for example, you want to subtract the mean in this column. But you only have one number in this, the 40 numbers, and each number represents the mean for each column. So you cannot just simply type like this one. For example, you cannot just type brand minus m, because they have different dimensions. The first one has the 1,200 by 40, but the second one has only 1 by 40. So if you do this, you will just subtract in the wrong way. Okay, so we need to write a simple script to do this one. So for this one, I will use the for loop. So for loop is one way to do the test repetitively. So for this case, I want to calculate to do the subtraction for each column. So I need to do this for 40 times because I have 40 columns here. So for each columns, I want to specify, now I want to calculate the first column and the second, or etc., depending on the I variables. So the variable I will beginning from the 1 and end at the 40. And so for this one, I just specify the I columns will equals to I columns minus the I order of mean and divided by the standard deviation. Okay, so the reason I say m parenthesis I here because I want to specify this is the ITH, the mean number value, and also this is the ITH, the standard deviation value. So that's that is the way we try to normalize the data. So normalization is that I subtract the mean and divide it by the standard deviation, so I can recalculate the distribution into the 0 mean and one standard deviation. So can everyone understand this part? Yeah. Any question? So if everyone can accept this part, then let's just try to execute these 3 lines here. So it's very quick. Then immediately we can just finish the calculation in the 40 columns. And when you look at the brain data here, you will see that it becomes that some are negative, some are positive. And if you just try to plot the first variable, you will see that it still have the same distribution. But the vertical, the axis here, the values becomes a zero mean. And the standard deviation is 1. Okay, so I didn't change any underlying characteristics. I just changed the mean and standard deviation. But for this way, the benefit is that the whole data will be normalized. So there's no single columns larger than the other one. Okay, so that's the very important part when you want to do machine learning here. So the normalized data is also important because if you try to plot this matrix using, like, I can show you how to plot this one. I can just type im show here. Remember in the first class I showed you how to plot the DICOM files. You can also plot anything, any 2-dimensional matrix here. So I just plot the red matrix here. Then you will see that there are the white dots and black dots. And the resolution of this is not very good, but on your computer you should be able to see there's more white dots in the lower half and like more black in the first half. So you can derive an intuition that, okay, so there is indeed a difference between violence of the male and female. So that is that is the basis that we can develop a model to differentiate these two labels. So this is very important because do not assume that you can do everything on your data. So for example, you have a data of containing lots of patients, and you already have lots of features for these patients. And you want to develop an algorithm to differentiate the disease 1 and disease 2. But when you need to look at the data, if you can visually identify the difference between them. If you cannot visually identify the difference, then usually you will not have a good model. So machine learning is not everything. You really have a reasonable data and hypothesis to have a good result. Okay. So suppose that you understand that this part of the normalization of the data, then we can prepare the data for the machine learning algorithm. So for this part, we just want to combine the features and labels. So the features is the brain violence, and the labels is the sex, male and female. So for combine these two, I just use this quotation mark to put the brain and the sex together here. Sorry. Let's copy this again. Okay, and paste into the MATLAB. Okay, so there's an ML data here. So it has a 41 column because the last one is the sex, and the one from column 1 to column 40 is the brain features. Okay, so the last part is that you can do this in the machine learning app in the MATLAB. So when you have just look at into the home. No, not this. Look at upper the section here. You can see there's APPS here, the tab here. So you can just click on the down arrow here, and you can see there are lots of toolbox and lots of apps. In the second row, you can see the machine learning and deep learning apps here. And the first one is a classification learner. Okay, so this is very convenient for you because although I will show you the detail in the future classes, but for now you can just click using this one. Okay, you can use classification learner. Let's just click on this one, and it will fire up an app to help you to do the machine learning. Okay, so it's just a blank window, but don't worry. You will see that there's a, okay, it still takes some time. Yeah. So you see that there's a new session here. So just click on the new session, the plus button here. Then you need to specify what is the data. Okay, so here you can see that when you select input, the input is actually the machine learning data I prepared in the class. So this is 1,200 by 41 matrix. I just select this one. Then you'll try to extract information here. You can specify the column as a variable or a row as a variable. So in this case, the columns are variables. And also you need to determine which is the response. Okay, so in this case, our response is the last one. This is the label of male and female. For the rest of the data, they are predictors. Okay, and you also need to specify how many cross-validation you will try to validate your data. I will explain the detail in the future classes. But for now, you just click the start session here. Then you will try to import the model here, and for this case, because you select the find tree here, and also if you click the down arrow, you can see there are different machine learning algorithms. For example, you have a decision tree model, you have a discriminant analysis model, you have a logistic regression model, and for this data, we can almost apply everything. Okay, so for example, if you want to apply a linear discriminant model here, I want to disable the parallel functions. Then try to click on the trend. Then I think, yeah, maybe. Then try to click on the ROC curve. Yeah, then you will see the linear discriminant model can achieve the area under curve of 0.91. And there are some other features you can derive the sensitivity and specificity, okay? So in this case, the sensitivity would be the 0.81, and the specificity is 0.85, meaning that you already have a machine learning model that can differentiate male and female in very high sensitivity and specificity in this position. So that is a very convenient part of the MATLAB that you can just using a machine learning app to do everything. But I think I want to show you the detail in the future class because although you can use the app to do everything, but the most important part you want to know how do we divide the data into training and testing, and how do we develop a model and try to evaluate the model. But for the case presentation one, I will encourage you to play these apps and to do the homework, okay? Okay, so that's the final slide. So I think everyone can achieve the same result here using the case materials. Okay, any questions?可以用中文问没有问题。
老师，像我们那时候报告的时候是要报那 AUC curve，还是报那个 accuracy？
Okay, that's a good question. So Junling asked that should we report the AUC curve or the accuracy or something else? I will show you in the next class what metrics we need in the report of this kind of result, because AUC is one of way to evaluate the performance. But oftentimes we need to know that what is the accuracy, what is the positive prediction value, negative prediction value, sensitivity, and specificity. And I will show you the meaning of those metrics in the next class. Yeah. Any other questions? Okay, so have fun.
Thank you.